Okay, so I'm going to talk to you, as Alex mentioned before, about AI use cases. As a forward, I like to mention that it won't be very technical, so we won't do deep dives into code snippets or similar things. It will be more of a consulting type of presentation, but I guess that it will still be interesting. Also, I think that it'd be fair that before I go into the presentation, that I briefly describe me and EPAM. I start with EPAM actually. So this is the place where I'm currently working on. So EPAM is a core software development company which in the last decade actually started getting into the data type of work. And also in the last 2 years, they started having offices here in Romania, physical offices in Bucharest and the Iași. In line with the global EPAM, let's say, we also have a data team here where we do well things data related, like data engineering, data science, data consulting. So, yep, you name it. Cool. Me myself, I've been doing all kinds of data related stuff till now. So I can guess you could say that I'm a jack of all trades kind of guy. Let's hope that the second part of the phrase doesn't apply, the one with master of none. Um, and at the moment, I'm currently focused on more machine learning related stuff. This being said, I jump into the presentation. Um, the agenda for this one would be represented by these three topics: entities and their three management levels, which is a bit dry topic, but mandatory for this presentation, I guess. Followed by selecting use cases and ensuring value. Also, I'd like to add that the presentation might not take the full length of the time slot, but yep, we'll see. Also, I think that considering that how nice the weather is outside, it would be a pity to have like a full length presentation. Um, Good then. So the first topic, splitting management across three levels. So one of the textbook ideas actually is that businesses on their management and planning uh, topics, let's say, can be split into three levels, which are strategic, tactical, and operational. They have like different characteristics. For example, strategy being focused on long-term activities and on the policies which the company has. Also, the questions which the strategic part tries to answer are why and when. The next one, the tactical one, is basically more or less a bridge. It's more about procedures and where and how things happen. And maybe the largest part would be the operational management, where the actual things happen, which is focused actually on objectives and what is going to be done. On the next slide, we have another type of split. Um, Basically, the functions within a company. As you all know, companies tend to get quite large quite fast, and they have like several business functions. Like for example, in this slide, I put a couple of them, which yep, are quite typical, like accounting and finance, sales, supply chain, production, R&D, or HR. The idea is that each of these entities more or less starts to become like a separate entity within the company with its own procedures and own governance. And if we are, for example, to link these two slides, so the previous one and this one, we will get to this kind of picture. So here, for example, here we have this drill down of the company to the marketing and sales entity, and after to the CRM one. And the main idea which I wanted to depict here is that these three levels of strategic, um, tactical, and operational somehow propagate. So they're like, I don't know, a state within a state, let's say. And this is quite important because, for example, because in each entity or sub entity, um, we can somehow group activities and group them into these three levels, so strategical, tactical, and operational. Actually, in the next slide, we have an example regarding, let's say, a CRM type of activity, um, which covers all these three layers. So we have, for example, I took as example customer service chatbot. So, for example, if it's a telecom company, then is that chatbot which you encounter when you call, I don't know, for a billing query or I don't know, phone upgrade or similar. And the idea is that this training chatbot um, basically is an AI use case, more or less, and there is a development there in order to train the actual chatbot by providing intents for the phrases which for phrases similar to what the users will type in. Using the data from this level, uh, we can use this data on the next level, so the tactical one, where you can create a churning algorithm. So basically saying which users might leave the company in the next, I don't know, next 6 months, which is an important feature, for example, at this level. And on the highest one, the strategic one, we can have some kind of forecasting, maybe like corroborating other data sources and feeding some, I don't know, executive spreadsheets, because yeah, people from the upper levels tend to prefer their Excel documents. Um, Good then. So if we can see here, these all are three AI use cases which have some different characteristics. And in the next slide, I try to outline a bit the differences between them. So basically, the idea is that um, the AI modules or ML modules, which are on the lower levels, tend to have a higher rate of usage. So, for example, in our chatbot example, the chatbot might have been called, I don't know, like 1,000 times per day, while those Excel spreadsheets with a forecasting bit might have been used for, I don't know, once a month or something similar. Then again, operational activities are much more granular. So them being much more granular means that they tend to solve line item things rather than aggregated data. In the previous example, for example, um, we didn't have the chatbot won't have like much data to use for this problem, while the forecasting one would have like data sources like the financial one, the user one, or the chat logs, or various output from the chat logs. What I've said here goes hand in hand with what we have here in the number of data sources. So uh, the given that the strategic level requires a much bigger picture, it means that this bigger picture can be can be better created with more data, and more data in a company basically means more data sources. Also, an important thing regarding the suitability of a use case for a specific planning/management level is explainability. The idea is that, for example, if we go to the chatbot, how the chatbot works doesn't have to be explainable to the client or to the person who uses it. And for this reason, we can go with more technical stuff. Like, for example, it will be quite hard to explain to a business counterpart or to the actual client how the chatbot works. So basically having, I don't know, a transformer model or some similar bird transformers, because at the moment they're basically black boxes, given that there are like a lot of parameters inside them that change. However, on the other side, we have the forecasting, which for the strategic level, most probably a linear regression or something simple would be the choice to go, because basically at that level, people want to know why things are the way they are. And yep, here basically is another concept that you have to decide how explainable your model must be against how performant it must be, because of course, usually neural nets or more advanced models can give better results, of course, if you also have the data for it. Um, till now, I guess that we've talked use about the specifics of use cases depending on the level on which they reside, but we didn't talk yet about how we actually find these use cases. And on the next slide, um, we have some kind of matrix which is designed, uh, which is basically for us which is of help for us to use it. The idea is that we as developers or consultants, we don't have actually the knowledge to come up with good ideas for the business processes which happen for the company which we work for or for the client which we work for. And the best thing to do actually is to let the stakeholders, which might be in case of a business process, the business users or other stakeholders might be technical, to actually imagine some ideas which they think that AI might be good for once they understood what can be done with AI. The idea is that at this step, it's basically like a child's play kind of thing. So it's a greenfield project. So basically, there aren't uh, bad ideas that they can give. All these ideas, however, they can be put in on this matrix. And getting back to this matrix, as you can see, it has two axes, on one of them we have the value of the use case, and on the other one we have the effort for building it. And basically here we are able to split this chart into a 2x2 matrix, and basically do a quick assessment to see if the proposed use case, then again the proposed use case by the client or the business stakeholder, uh, can be implemented and is actually valuable. And we can split them across these four values, which are wow, how, now, and no. It's actually, again, a textbook kind of matrix. It's been used like I don't know, for quite a time now. And the idea is basically that the wow the wow square, the wow corner, so what we have in upper right is about high value use cases with a low effort, so things which are total winners. On the upper right side we have the how bit, so there are still high value cases but implementing them is quite difficult. And on the lower left one we have quick wins basically. Going with the example which I provided in the previous slides, I pinpointed the three AI use cases on this matrix. And for example, we have NLU model for chatbot training, which of course it's a high value activity, considering that it diminishes the operational effort for all the call agents, but also it's a high effort considering that in the start at the start of the activity you won't have like labeled data, you will have a bunch of unstructured data which would have to be cleaned and grouped somehow, maybe I don't know, by similarity of the sentences in order to get some kind of pseudo classes, which of course takes time and isn't a and is a process which isn't perfect by any means. Um, Under the wow group, I put customer churning algorithm because basically the data, if the NLU model is going to be built, then doing some further analysis with some internal user data and what the chatbot model outputs is going to be quite simple. So it can be an important win, given that, for example, I don't know if we have clients which we can predict that they are going to live in 6 months, maybe we can do some kind of promotional offer from them, or a fidelity program or things along those lines. So then again, to be of high value. And in the now box, I put the strategical one, so the cost optimization forecasting. The reason why I put it here, for example, is that it is a low effort because basically it will be like a regression of some parameters which the business or the stakeholders might find valuable, but it's also of low value because at that level, I'd suppose that the people which do the decisions are quite aware of how things influence one another. Uh, Good. Uh, at the moment, we also discussed a bit about how to select use cases. Now we are going to talk about the fallacies of developing and basically how to maintain value. Um, okay, one moment. Okay. Uh, Also, if there are any questions, it's a bit hard for me to see them at the moment, so it will be easier for me if I just answer them at the end, given that PowerPoint keeps up two screens. Good. Onwards to the next slide. It might be the least effort slide in this entire event, but it's about the common perception which stakeholders usually have about ML models. So the idea is that they usually believe that you have data somewhere in your systems. It doesn't matter its state too much, or they believe that it's in an usable state. And the only thing to do would be basically to apply a model and just stick it somewhere in the system and output the results. The idea is that this isn't the case at all. And in order to ensure value and maintain value of what is going to be built, we are going to need additional things. This kind of very loose and unpleasant model may work for fast things like POCs and so, but when things are going to enter into production, it's going to be an unpleasant experience if this stays like in this slide. And some of the caveats which have to be mentioned before embarking on building AI use cases, some of them are the following. The first one would be AI readiness. So the idea is to see if a company is mature enough to support AI use cases. And I think that there are two main um, topics which have to be tackled. The one would be to have data, reliable data, which we'd actually talk about in the next slide. And the second one would be about understanding that AI is as development as it gets. So that you need to have like the environments as you were doing a normal software development type of activity. Um, Good. The second one would be very confirmation. So the use cases which were selected and drafted on the previous exercise, which can actually be a workshop kind of exercise, have to be reconfirmed and see if they actually make sense and if they are in line with what the company wants. So the idea is that it won't make much sense to build some kind of to build on some kind of use cases if they become obsolete or non-relevant in the upcoming period, since usually ML and AI solutions require a lot of support afterwards. Which brings us to the last topic in this slide, which is about support, and that it's important to have support from multiple stakeholders, let's call them. So in order to build these kind of solutions, you need to have architectural support, business, production, and maintenance as well. Architectural because, as I mentioned before, AI solution and components have to be part of a larger picture and just not glued in somewhere in the system. Business support because the idea is that AI solutions aren't usually overhead and they are supposed to actually bring value. So we do need to have someone from business uh, there for us so that they understand what we're doing and vice versa. And we also need production and maintenance since yep, AI components can break, and this also has to be taken into account and mentioned many times, I'd say. Um, Good. Going back to the data topic, um, companies also have to have a maturity in data. Here on the left side of the slide, we actually have like a copy of the SAP LSA, which I think that it stands for layered scalable architecture or something along those lines. Is actually presents tidiness in data and consolidating it and further sending it to the places where it's needed, like other applications or queries or other yep, other apps. The idea is that in order to get results, you do have to know where the data resides, and you also have to be aware of this data governance topic, which goes hand in hand with the layers. So in order to build reliable AI solutions, you have to be aware of things like data lineage, of protection and compliance, basically to see if that data makes sense, and if it's compliant to use it actually. So a lot of the data, especially if it's production data, for example, it has to be removed of any PII data. There also might be retention rules applied on them. We also have to know that the data is consolidated. So, for example, for a specific process, we do have to know that the data on which we are building something is somehow relevant for the entire data set, and that you don't have like missing pieces of data which might cause us to build bad models. And one of the and the last thing actually on this slide is the data drift, which is a concept which started getting attention quite recently, I'd say. Idea is that AI models they're basically built on data, so they rely on useful and reliable data. But the idea is that data over the course of time tends to change, so the initial model isn't reliable anymore, and this can happen. I don't know. For example, for the chatbot model, uh, 10 years ago we'd have had, I don't know, Nokia and Blackberries, and now we have like lots of iPhones. Here, for example, the inquiries of the users might change, and if the data isn't verified and the model isn't retrained, then this would impact the ultimate experience the user is going to have. And basically, after these two slides about uh, various caveats and warnings about data, I'm going to move on to the next slide, which is about the need of having a ML ecosystem or ML operations place. And which isn't composed only of data and model. It has data, of course, because we have to know which the data sources are, but they vary, but they might vary and they might be different. And given these facts, we do have to be aware of their lineage. We also need to have places where we can save our models. We also need to have a place where we can work and experiment with new things, which is basically a separate things on what happens in the ML production pipelines. We also have to have development like tools, so basically having source control, maybe CI/CD pipelines. We also need to have ML specific tools like ML pipelines, like tools which can create ML pipelines, which can be out of the box cloud tools or yep, custom built tools. We also need to build images or use Kubernetes in case we need to have to deploy APIs, to deploy models which are exposed as APIs. And we also need to do ETL work, or we need to do orchestration work. So basically leveraging tools like Airflow, Amazon Glue, or in case of ETL tools, I don't know, Databricks or Data Factory or similar. So as you can see, um, the ecosystem is quite large, and the tools needed to successfully maintain value are quite many, and this can be a risk of not providing value over time, as business and the stakeholders usually consider that poorly drawn schema on the previous slides. Other than that, I think that would be all. The takeaways for the presentation would be that different management levels have different needs, and basically the AI use cases which they would like have to be tailored specifically for each one of them. The second would be that not all entities are AI ready. Entity might mean either a company, either a part of a company, And yep, that basically needs to be assessed if any AI solutions can be built on top of what they have. And the last takeaway would be that AI solutions tend to need continuous support and basically having MLOps behind them. And I guess that's it. If you have any questions, now I'm going to be able to see them.